Here we go. Our objective for today. I can write, identify, and graph parallel and perpendicular linear equations. Let's read together. 1, 2, 3. I can write, identify, and graph parallel and perpendicular linear equations. You don't need the Freire model, which means you don't need the little box that we draw, right? Because we already know what linear equations are. But today, we're going to look at a set of lines or equations that are either parallel or perpendicular. Okay? So once again, we don't need a Freire model. We do need steps. So copy these 5 steps. It's only 5. So once again, we already know what linear equations are, what they look like. Go to steps. 5 steps. Copy these down, please. Number 1, solve for y and write the equation in slope-intercept form. Do we know how to do that? Yeah, we did it in the warm-up with example number 4. Remember that? Number 2, compare the slopes and intercepts and identify if the lines are parallel or perpendicular. Number 3, identify and plot the y-intercept. Number 4, identify and use slope to plot points. And at the end, graph your lines. We know how to graph using that method. So copy that and then we'll continue. Go. So, 5 basic steps. We're going to go over these just to make sure we know how to identify parallel and perpendicular lines. So here we go. So first, let's clear up definitions. I'm going to start with parallel lines. Don't write this down, just pay attention. It says, parallel lines are lines in the same plane that have no points in common and will never intersect. Now, this concept you already covered some time back. And your teacher showed you guys, and the one thing that you remembered from this definition is that they never what? Intersect. Remember that? But today, I want us to understand that definition, but understand it from the point of the equation. So check this out. Let me show you the graphs with their equations. There it is. And we're going to come up with a definition using the equations. So check this out. I'm going to go ahead and erase this definition. And we're going to come up with another one using the equation. So look up, please. Here's the equation for this blue line, and here's the equation for this red line. So think about it. What do these 2 equations have in particular that we can write our definition for parallel lines? Look at it. You already know some terminology according to these lines or according to these equations. So talk it over with your neighbor. What would you tell your neighbor according to the equations that these 2 lines are parallel because of what? Look at this. Talk it over. Go. Write this down. Parallel lines are equations that, so now this is where you're going to help me out. What is the first part, Russell? Parallel lines are equations that what? Never parallel. Okay, I said we weren't going to use that definition. I said from your discussion with your neighbor, you were going to give me some information from these 2 equations. First part, yes, Mark. That have different y-intercepts. And what value do we use for that? B, okay, comma. So now that we got us in the right direction, how about the second part, Russell? Parallel lines are equations that have different y-intercepts.
And have different x-intercepts.
Whoa!
That's what you saw from those 2 equations? Callista.
They have the same slope.
and have the same slope. And what do we use for that? M. 10Q. All right? So, let's see. Look at the two equations. Look at the lines. Do they have the same slope? Yes. Do they have different y-intercepts? Yes. So those lines are parallel. So with that said, who can give me another line that is parallel, or another equation that is parallel to these two? Talk it over with your neighbor. Give them yours to see if that makes sense. Give them an equation that's parallel to those two. Go. Russell. Example. What is your line parallel to those? Give me an equation.
Alright, so y equals 1/2 x plus 23.
23, Michael Jordan. You know what? Extra credit, Russell.
Yeah!
Do you agree that this line is parallel to these two? That is correct, because they have the same slope, different intercept. That is correct. Who can give me another example? Go ahead, Logan. Plus 7. Hands, have you got that? Anybody get that? Does everybody agree with that? Yeah? One last one. Go ahead, Carson. Plus 25. All right. Now, who notices that everybody's been giving me just positives? Okay, who can give me another one? Gabriel. One half x. Is that also parallel to those? Yes. As long as they have the same slope, different intercept. Does everybody agree with that? All right, let's move on. So, did everybody write these down? Yes? All right.
Oh, wait, no.
Focus, please. So, no, just write a couple of them so that you have my examples. So we're done with parallels. Let's go to perpendiculars. It says, perpendicular lines that intersect to form right angles, which means 90-degree angles. So before I give you the actual example, look up, please. Look at the previous example. Don't say it out loud. Do you see those lines that are perpendicular? Don't say it out loud. Keep it to yourself. Talk it over with your neighbor. Let them know why those are perpendicular. Who saw that the coordinate plane itself, the x and the y-axis, form 90-degree angles? Hands if you saw that. Okay? Here it goes. If you don't see it, let me show you. Here's the x and the y, and when they intersect, they make 4 90-degree angles. 1, 2, 3, 4. Do you guys see them? Okay? All right? So, that means that the x and y axes are perpendicular, right? So now let me show you two more lines that are perpendicular. There they are. Let me move this a little bit further this way. All right, so watch. Look at these two. This red line and the blue line. They're perpendicular. Don't copy that, just pay attention. Now, we're not going to use this definition because we already know that they intersect to make 90 degrees. But what we are going to do, we're going to come up with our own definition, again, according to the equations that they gave us. So, think about it. Look at these two equations. Don't say it out loud. And see if you notice something that you can talk over with your neighbor in regards to why it makes them perpendicular. Look at this one. Look at that one. I'll give you guys some time. Talk it over with your neighbors, please. I'm going to get you guys started with the definition. So you're going to write parallel lines. Perpendicular lines are equations that have. All right. So with that said, who can get us started or going with the rest of the definition? Vanessa. That have the slope is the reciprocal. You're close. Look up, please. Did everybody see that the slopes are reciprocal? Are they reciprocal? Almost, right? Reciprocal what? Damn, Victor in the house. The slopes that have the slope, let's see, are equations that have the slope. That doesn't sound right, right? That have the slope, which is reciprocal inverse, 10 Now check this out. Look at this one. What is the reciprocal of 2/3? 3/2, right? But what sign is this one? And what is the inverse of a negative? That's why it's reciprocal inverse. Now notice that I ended the definition. So what does that mean? That the y-intercept doesn't really matter. It could be the same or it could be different. Now check this out. Let me give you an example of the y-intercept being the same. Watch. Does everybody see how the red crosses right here? Yes? Are these still perpendicular? Do they have the same y-intercept? Yes. So it doesn't matter whether they have the same or different, they're still perpendicular. As long as they have what kind of slopes? Reciprocal inverse. What kind of slopes? Reciprocal inverse. Does everyone understand that? All right, so now that we got that out of the way, check this out. Copy these. Write example 2. And I want you to write y equals 2x minus 3, semicolon. Y equals negative 2/3 x plus 3, semicolon. 2x plus 3y equals 8, semicolon. Whoops, sorry. And y plus 1 equals 3, parentheses, x minus 3, close parentheses. Copy those, and then we'll go ahead and I'll go and walk you through that example. Go. All right. Can you read us step 1 from your notes, please, Julian? What? Read it again, please. That is correct. Solve for y and write the equation in slope-intercept form. So look at the first equation. Is it solve for y?
Yes.
Yes. Is it slope-intercept form? Yes. Second equation, is it solve for y? Is it slope-intercept form?
No. Yes.
Yes. The third one, is it solve for y?
No.
No. So let me zoom in on that one so we can solve for y. We're going to do this one together. So, line down the equal sign. And right now we're focused on this one right here. This one right here. Okay, so what do I need to do to leave y by itself, everyone? Subtract 2x, subtract 2x. We're left with 3y equals negative 2x plus 8. What's my next step? Divide by 3, divide by 3. Y equals, we got negative 2 over 3, so that's negative 2 over 3x plus, how many times does 3 fit into 8? 2 and 2/3. I'll leave it at 2 and 2/3. All right, so we're done with that one. How about this last one? Is this one already solved for y? No. Line down the equal sign. Help me with this one, Sebastian. What do I do? Distribute. We're left with 3x minus 9 equals y plus 1. Continue. Focus. Subtract 1. Very good. Y equals 3x minus 10. Stay behind, please. Are we there so far? So, is this one already solved for y? Yes. Is it slope-intercept form? Yes. How about this one? Yes. So with that said, let me zoom out. So, question, identify which lines are parallel. So what are the two things that need to be met in order for them to be parallel? They have to have the same what? Slope and different y-intercept. Which one of those have the same slope? Y equals negative 2/3. Do they have different intercepts? Yes, this one's 3 and this one is 2 and 2/3. So, to write out that these two are parallel, you write this out. Y equals negative 2/3 x plus 3, and this is the symbol for parallels. Look up. Are parallel to y equals negative 2/3 x plus 2 and 2/3. Yes? Now, are there any others? Let's see. What is the slope for this one? 2. What is the slope for this one? 3. So I guess we're done. You understand what we're doing? Okay. And that's all it is, pretty much. Check this out. I'm going to give you 4 more. You don't have to write them down. Look at these. Don't say it out loud. I have line A, B, C, and D. Talk it over with your neighbor. Let them know which ones are parallel and why. You don't have to write anything down. Just explain to them which ones are parallel and why. Go. All right. Let's see. Help me with this one. Michael. Which ones are parallel? A is parallel to B. Why? Because they both have the same slope and their y-intercept is different. Does everybody agree with that? Yes. That's pretty much it. Do we have any others that are parallel? No? Okay, we'll stop right there for that part. Now we get to the funner part. Yay. Copy this. It says, show that JKLM is a parallelogram. So You have your graphing paper, right? Use a bigger one. Yeah. And here are the points. They give you points. This one, point J is negative 1, 3. Point K is 3, 3. Point L is 2, negative 1. And point M is negative 2, negative 1. Copy that. Then we'll go over this one together. Go. All right, here we go. So, first things first. To prove or to show that this is a parallelogram, the definition of a parallelogram is that the figure has to have two sides or two pairs of sides that are parallel to one another. So that means we need to prove that this side is parallel to this one. So, what can we do? What can we do to find out if this one is parallel to this one? Look at it. Does everybody see? Look up. If I was to do this, so how can we tell whether this one is parallel to this one? By finding what? The slope from this point to this point. So what is the slope from this point to this point? Let's see. 1, 2, 3, 4. And how many to the right? 1. How about this one? 1, 2, 3, 4. And 1 to the right. Do they have the same slope? Yes. So we're going to write, first I'm going to start with this segment. Look at the name of this segment. This segment is segment MJ. No, it's MJ. Michael Jordan. Is parallel to segment LK. And why? Because the slope of MJ is what? 4 over 1, which is parallel to slope 4 over 1 of LK. Are we there? So with that said, what is the slope of JK? What is it?
I don't know.
We need to finish this.
The slope of that?
When it's flat like this, what kind of slope is that? 0. 0. So therefore, slope JK is parallel to slope ML because both slopes are 0. So our home plate for tonight, pages 207 through 208 and 274. Good one, guys. There's tutoring today. If I don't see you here, see you guys tamales.